Let's look at example 1. Calculate the energy of a photon of blue light with wavelength 450 nanometer. So we want to calculate energy when wavelength is 450 nanometer. Okay, since in this subtopic we are going to use this formula only, di mana energy is equal to HF ataupun energy is equal to HC over lambda. So since we are given the lambda here, so kita akan gunakan this formula. E is equal to HC over lambda, di mana H adalah Planck constant which is given here. C is the speed of light given here as well, and then lambda is just the wavelength given. So just masukkan 6.63 exponent negative 34. So constant, value constant ni memang akan dibagi dalam exam ya, so don't worry about that. You don't need to hafal, just tengok sahaja dekat list of constant dekat depan. And then lambda, which is 450 nanometer. And all of these constant value are already in SI unit, so you don't need to convert that one. So energy will be equal to 4.42 exponent negative 19 joule. Okay, so dalam formula ni kita kena letak jawapan akhir dalam electron volt, this one. EV is electron volt. So you need to convert this energy to electron volt. So it's already given here, di mana 1 electron volt is equal to 1.6 exponent negative 19 joule. So we want to convert daripada joule kepada electron volt. So from here to here, so kena bahagilah. So you need to bahagi 1.6 exponent negative 19 joule. So final answer will be equal to 2.76 electron volt. Okay, kita tengok example yang kedua. A photon of green light has a wavelength of 520 nanometer. Calculate the photon's frequency and energy, which is energy must be in joules and electron volt. So we want to find frequency and energy. And then we know that energy is equal to HF, also equal to HC over lambda. So first kita boleh cari frequency. How to find frequency? Since kita ada dekat sini is this one, right? We want to find, since we are given this one, so we can find using this formula. So HF is equal to HC over lambda. So H dekat sini boleh cancel out. So F will be equal to Cx is 3 exponent 8 divided by lambda. So frequency will be equal to 5.77 exponent 14 hertz. Okay, so that's the first one. Second one is we want to find the energy. So energy using this formula only. Energy is equal to HF, di mana H is H is equal to 6.63 exponent negative 34, and then times with the frequency. So akan dapat energy is equal to 3.825 exponent negative 19 joule. And then since they minta in joules and electron volt, so we have in joules, so kena convert kepada electron volt, which is bahagi 1.6 exponent negative 19. So akan dapat E will be equal to 2.39 electron volt. Okay, so that's very easy. Example 2. So kita tengok last example, example 3. So a photon has energy of 3.2 electron volt. Calculate the frequency, vacuum wavelength, and energy in joule of the photon. So we want to calculate 3 benda, frequency, wavelength and energy, which is in joule. Okay, so first kita boleh cari energy dahulu. Since energy is given in electron volt, E is equal to 3.2 eV. So we want to convert to joule, which is darab dengan 1.6 eksponen negatif 19 joule. So akan dapat 5.12 eksponen negatif 19 joule. Okay, and then we want to find the energy sudah. Now we want to find frequency. So E is equal to HF. This is the one that we want. So energy. Okay, so this one, since H dekat sini adalah in joule, right? H ni dia punya unit adalah dalam joule. So E dekat sini must guna this one in joule juga. So 5.12 eksponen negatif 19 equal to 6.63 eksponen negatif 34 times with frequency. So frequency akan sama dengan 7.72 eksponen 14 Hz. And then last one we want to find is wavelength. So we have F is equal to C over lambda. This formula, kita boleh gunakan formula ni ataupun boleh gunakan E is equal to HC over lambda. So sama je lah, kamu akan dapat jawapan yang sama. So kita gunakan this formula, di mana F adalah 7.72 eksponen 14 equal to C. C is 3 eksponen 8 divided by lambda. So lambda akan sama dengan 3.89 eksponen negative 7 meter. Okay, so that's all for example 1, 2 and 3. Thank you.